In this video, we are going to continue studying solving systems of equations by elimination. Here we're going to deal with what happens if nothing eliminates from the original problem. So when we look at the example here, we have 4x minus 3y equals 15 and 2x minus 3y equals 9. Normally, we would look to see if there are two coefficients that have the same value, and there are. We have negative 3y and negative 3y. So instead of adding the two equations and adding the stacks of values, we actually have to subtract everything. But the other thing that we could do is you could actually change the second equation, or the first one, by multiplying everything by negative 1. And if you multiply everything by negative 1, what happens is in the first equation, nothing, because we're just leaving it alone. But in the second equation, all of the signs change. So we now get negative 2x plus 3y equals negative 9, because we multiplied each term by a negative 1. When we do that, well, now we do have coefficients that are opposites. So the negative 3y and the positive 3y now cancel out. We end up with 2x equals 6. We can divide by 2 on each side, and we get x equals 3. Then to complete the problem, we take that 3 and we plug it back somewhere into one of the original equations. I'll use the first one. So 4 times 3 minus 3y equals 15. End up with 12 minus 3y equals 15. Subtract 12 from both sides. I now have negative 3y equals 3, which means when I divide by negative 3, I'm going to get negative 1. So my final solution is going to be 3, negative 1. Remember, I can go ahead and check that by substituting those values back into an original problem. So I'm pretty confident they're going to work in the first one because I kind of just did that. But let me put them in the second one. So 2 times 3 minus 3 times negative 1 equals 9. I get 6 plus 3 equals 9. That is true. So I'm pretty confident that my answers are correct. All right, so just to recap, we had these two original problems, and we couldn't eliminate because none of the values were opposites. So what we did was we multiplied by a negative 1 in order to change the signs, and when we did that, we ended up with coefficients that were opposite, and we could eliminate. So let's look at this second example. In this second example, again, we've got 2x plus y equals negative 9 and 4x plus 11y equals 9. So again, we've got no coefficients that are equals, or sorry, opposites. Like we don't have 4 and negative 4 or 7 and negative 7. And so we're going to have to multiply one of the equations by something in order to get opposites. I suggest that we take our first equation, and if we want to eliminate x's, I need to make this 2x into something that would eliminate with this 4x. Well, let's multiply by what would give us the opposite of 4x. Well, what's the opposite of 4x? Negative 4x. So if we multiply by negative 2 everywhere on this equation, we end up with negative 4x minus 2y is going to be equal to positive 18. Then we can just move over our second equation, which was positive 4x plus 11y equals 9. So now our x's eliminate. We end up with 9y equals 27. We can divide by 9 on both sides and we get y equals 3. Then to finish it off, we'll take that 3 and we'll plug it back in to one of the equations. I chose the first one. I'll subtract 3, so I get 2x equals negative 12, which means x is going to be equal to negative 6. And I finish it off by writing my solution as a coordinate pair. Again, I can do a little mental check to see if the information is correct. So I can plug the negative 6 into this equation here, and I would get negative 24, and if I plugged in 3, I would get plus 33. And does that in fact equal 9? Yes, it does. Therefore, I'm pretty sure that, or I'm confident that my answer is correct. All right, let's do another example. Here, go ahead and take a look at the example and then take a second to figure out what you want to change and how you would go about solving it. So pause the video here and think about that. When I look at this video, I see, first of all, my variables are not lined up with each other. The x's and y's and everything are not lined up. So the first thing I'm going to do is I'm going to rewrite the equations so that my variables are lined up. So this first equation, I'll just leave it the way that it is, 2x minus 3y equals 6. And the second equation, I'm going to add the 7x to both sides. So now I have 7x plus 4y equals negative 8. Okay? Now, in this case, again, we have a system of equations, and neither the x's are going to eliminate nor the y's. And in order to make something eliminate, I'm going to actually have to multiply both equations. So the first thing that pops to mind is that it's going to be easier for me to eliminate the y's, but you could certainly do this with the x's. So I'm going to start by thinking, if I multiply by some number, will it give me another number that allows me to eliminate y's? So I'm going to multiply by 4 everywhere, which will give me 8x minus 12y equals 24. And for my second equation, if I multiply by 3 everywhere, it'll give me 21x plus 12y equals negative 24. Great. So now we have the y's set up so that they eliminate, and I end up getting 29x equals 0, divided by 29 on both sides, therefore x equals 0. Then I take the x equals 0, plug it back in, so 2 times 0 minus 3y equals 6. And then we divide by negative 3 on both sides, and you get y equals negative 2. So the coordinates would be 0, negative 2. So in this case, first we had to rearrange the equations so that everything was stacked up. That's what happened here. And then we had to multiply both equations by a coefficient. And notice they were different numbers, so that didn't matter. Sorry, by a constant. So that didn't matter. So I multiplied this one by 4 in order to get negative 12y, and this one by 3 in order to get positive 12y. I could have multiplied this first equation by 7 to get 14x and multiplied this equation by like negative 2 to get negative 14x. That would have been fine. It doesn't really matter which numbers you choose. You just got to get something to eliminate.